Good afternoon, everybody. We will begin with today's program. We start with the inaugural session. May I request Professor Deepak Ghosh, Professor Ashoknath Basu, Professor Swapan Kumar Pramanik, please come on the dais and take your seat. I will request our President, Professor Swapan Kumar Pramanik, to offer the flower buds to Professor Ashoknath Basu and Professor Deepak Ghosh. কোথায় Professor Sujit Kumar Das, our treasurer, with the kind permission from the chair, we begin today's session. I, on behalf of the Council of the Asiatic Society, extend to all of you a very, very hearty welcome. And though late, but let me also share with you a message of Happy New Year, because we are meeting in physical mode after so many months. It gives us a fresh lease of life, in a sense. So it's a really remarkable day for us. More remarkable, the program which has been dedicated to the memory of an eminent scientist of this country, who at least to many of us until the other day was not very familiar. But frankly speaking, when we heard it about his eminence and his attainment of scholarship and his research contributions, it was told that he almost narrowly missed Nobel Prize. Such was his height of thinking and originality of producing the result of research at a time when, unlike the present time, many opportunities were not available. So the moment this proposal came to us, through the courtesy Professor Ashoknath Basu, Professor Deepak Ghosh, we readily accepted it. The Asiatic Society has still to remember a connection with Professor Syamadas Chatterjee, who almost at the end of his life donated his house, which is situated in Baliganj, for the use of Asiatic Society. And I am told that in his collection, apart from the rare books, etc., some remarkable specimens in the form of microscope, which was handed over to him through Madame Curie via Satyendranath Bose to S.D. Chatterjee. And even now, this would be available there. So now we have a mission to somehow go for reorientation of the building, conservation of the building, and after this is done, to initiate certain areas of academic activities, especially focusing the history of science, which was a preserve for the Asiatic Society in the years when it began, since 1784. Until middle of the 19th century, this was the only place where, apart from other Indologists, scholars of language, linguistics, folklore, anthropology, art, architecture, it was also the center of excellence for cultivation of science in various forms, especially the history of science. Our founder was very keen on exploring the possibility of looking at the roots of excellence of this country in all walks of academic activities, science, art, history. This was the beginning. And we are happy to note that we have been able, over the years, now we are on our 239th year of existence, glorious existence. We are keen to carry forward the legacy that we have received over these years through generations, to not only maintain the present status, but also to carry forward still at a higher plane, where this center could be one when we can think of many more academic activities, programs. Apart from Professor Ashoknath Basu and Professor Deepak Ghosh, Professor Debashish Ghosh, Professor Vikas Sinha, they have also expressed their keen interest in reviving the activities of Asiatic Society in the area of science cultivation, especially the history of science. So let us hope that the beginning that we have been able to start very modestly today in the afternoon in this historic hall of this historic building, which has been dedicated in the name of Sir William Jones. You must have noticed outside that this is Sir William Jones Bhavan and this is Vidyasagar Hall. So with these few words, I again welcome you all to this very important program, and thank you very much. Now, about this seminar, this will be addressed by Professor Deepak Ghosh. Sir.
Respected President Professor Pramanik, Professor Ashoknath Bose, Dr. Basu, Professor Sinha, Professor Debashish Ghosh, Dr. Maniklal Maji, and all distinguished guests. This is a rare occasion in my life. I was a student of Professor Syamadas Chatterjee. I recall when in 1938, Italian physicist Enrico Fermi obtained Nobel Prize for discovering transuranic element. And you all know the interpretation was wrong. That was not transuranic element. Because at that time, uranium was bombarded with neutron, recently discovered at that time, to get something new. And his interpretation was wrong, and ultimately it was found that there is a peculiar process that uranium itself is breaking into two parts with tremendous amount of energy. At the same time, in 1938, in Kolkata, a young research scholar, Syamadas Chatterjee, below the age of 30, joined Bose Institute as a scholar doing the same experiment with uranium. And he did the experiment of having some fission cross-section with the help of neutron from iridium beryllium source. But during this experiment, suddenly he found even when the source was not there, the neutron source was not there, there is signal of fission. He was scared. He showed many students and colleagues, and ultimately to Professor S.N. Bose, who suggested might be there is a spontaneous fission. So, Professor Chatterjee actually discovered spontaneous fission. He repeated the experiment and he wrote a paper, but somehow it could not be published. So that was his first achievement in Calcutta by a Bengali scientist discovering spontaneous fission. 2 months later, Petrak and Flerov from Russia published the paper in Physical Review. From that, he had the expertise to construct high-quality Geiger-Müller counter, high-quality Wilson's cloud chamber comparable to Europe and United States. Ultimately, he joined Jadavpur University in 1956, and I was his student from 1961 to 67. Then I joined as a research scholar, and then I worked with him till 1970. By this time, he did many experiments pioneering in cosmic ray, in radiocarbon dating, and environmental radioactivity. After his retirement from Jadavpur, he was associated with S.N. Bose lab in cultivation of science, and he did a lot of work in Bokreshwar. And Professor Vikas Sinha and Devashish Ghosh gave a new dimension to the helium project, and today, you know, it is a grand success. Now, at my later age, I am about 77, I decided that practically Professor Chatterjee is unknown to Bengali community, more so to Bengali scientists. So I simply, as a popular book, I wrote a book. Professor Chakraborty was kind enough to read the book, and he was surprised that a scientist of that caliber did something which is unknown to us. And he decided to do many things because this is 75th year of Indian independence. What he has said, the first thing is the seminar. Before that, I wrote a book, Bokreshwar Upakhan, autobiography of Syamadas Chatterjee, that was published. And next, the building of Syamadas Chatterjee, which is named as Professor S.D. Chatterjee Research Foundation. Asiatic Society, it is a matter of great privilege to us that will be a center of excellence doing natural science and philosophy. So today, just the beginning, many eminent scholars, eminent veteran speakers, including Professor Sinha, will revisit Dr. Chatterjee's work, and at the same time, some eminent scientists will say something about the frontiers of science. Today is a very auspicious day because in the name of Professor Chatterjee, we are having a new journey from this seminar to establishment of a center of excellence. I hope with all your blessings and cooperation, this will be a new center of science and philosophy in Kolkata. And last but not the least, the stakeholder of this should be the young generations. Otherwise, there is no meaning of doing seminar because half-life of seminar is very small. So, my point is this. Today's deliberations will be published in a monograph, and at the same time, those things will be written in Bengali for school students, and we will publish it. And there will be extensive activity of popular science writing in Bengali. I thank you all. If you have any suggestion after this seminar, you can leave it. And it is a great privilege for me to honor Professor Chatterjee, and Asiatic Society has taken the leadership as they have taken in many areas. Thank you very much. With these few words, I should conclude. Ayam Arambho Shubhayo Bhavatu.
Before I invite Professor Ashoknath Basu to say a few words entitled Professor S.D. Chatterjee and His World. Just now you have heard about the Bokreshwar Upakhyan written by Professor Deepak Ghosh. This was released in the International Calcutta Book Fair on 5th of this month in the Press Corner, and it has already received acclaim from many corners of the academics, and I am told by the office today that still about 25-30 copies are available in our publication section downstairs. Those who want to lay their hand, this is probably priced $250, but today it will be sold out at 50% discount, that is $125. Please, whoever likes to have a copy can contact the publication section downstairs. So, Professor Ashok Nath Basu.
নমস্কার, মাননীয় প্রেসিডেন্ট, সেক্রেটারি, ট্রেজারার, এশিয়াটিক সোসাইটি, বন্ধুবর প্রফেসর দীপক ঘোষ, বন্ধুবর প্রফেসর বিকাশ সিনহা, বর্মন and other distinguished members. শ্যামাদাস বাবুর ব্যাপার নিয়ে আজকে যে সেমিনার, এখানে শ্যামাদাস বাবু অ্যান্ড হিজ ওয়ার্ল্ড এ নিয়ে আমাকে দু একটা কথা বলার জন্যে খুব ভালো করেছে। তা শ্যামাদাস বাবুর সম্পর্কে, এবং সময়টা খুব একটা বেশি না, 10 মিনিট 15 মিনিট। আমি ভাবছিলাম 10-15 মিনিটের মধ্যে শ্যামাদাস বাবুর সম্পর্কে আমি কি বলতে পারি। আমাকে যদি আপনি 10 ঘন্টা সময় দেন, আমি কন্টিনিউয়াসলি বলে যেতে পারি। আপনি যদি আমাকে 10 দিন সময় দেন, তাও আমি কিন্তু সবটা শেষ করতে পারবো না। সুতরাং আজকে আমার পক্ষে কি বলা উচিত, এটাই আমি ভাবতে ভাবতে আসছিলাম। হচ্ছে আমি 2-4টে মন্তব্যের মধ্যে সমস্ত বক্তব্যটাকে সীমাবদ্ধ রাখবো। তাতে ও মানুষটা কেমন, এরকম একটা ফিলিং হয়তো আপনাদের মধ্যে আসতে পারে। এবং আজকে এই যে নামকরণ করা হয়েছে, কে নামকরণ করেছে কি জানি না, অসাধারণ নামকরণ, যে ম্যান অফ স্প্লেন্ডার্স। এবং এইটুকুন দিয়ে শুরু করি। ও বিকাশ, তুমি দিয়েছ? ঠিক, আমি একটা ভাবছিলাম কে এই নামটা দিতে পারে। সে তো বিকাশের কথা পরে আপনারা শুনবেন। প্রফেসর সিনহা আমাদের বিশেষ বন্ধু শুধু নন, বিরাট ফিজিসিস্ট। যাকে আমি আমার কথায় আসি, যে প্রথমে শ্যামাদাস বাবুর সাথে আমার পরিচয়, আমি যাদবপুর ইউনিভার্সিটিতে 60-এর দশকের মাঝামাঝি পড়াতে গেছিলাম। সেই সময় তার সাথে কিন্তু আমার খুব একটা বেশি দিন ওখানে থাকা সম্ভব হয়নি। কিন্তু উনি 3-4 বছর পরেই তিনি যাদবপুর থেকে চলে আসেন, কিন্তু তার সাথে তার মৃত্যু পর্যন্ত আমার যোগাযোগ ছিল। এবং সেই ভিত্তিতে দু একটা কথা বলি, যে যাদবপুর ইউনিভার্সিটির ফিজিক্স ডিপার্টমেন্ট ছিল একটা ইঞ্জিনিয়ারিং স্টুডেন্টদের ফিজিক্স পড়ানোর একটা ছোট্ট ডিপার্টমেন্ট, 3-4 জন লোক এর একটা ডিপার্টমেন্ট। শ্যামাদাস বাবু সেই ডিপার্টমেন্টটাকে, উনি মাত্র 15 বছর ছিলেন ওখানে। একটা মানে আন্তর্জাতিকভাবে পরিচয় তার সৃষ্টি হয়েছিল, তার গবেষণা কাজের জন্যে, তার পড়াশোনার জন্যে, এবং নানা দিক থেকে। তা সেই ডিটেলসে বলতে গেলে তো তিনি কি কি করেছেন সেখানে আমাকে বলতে হয়। তো আমি একটা রাফ হিসাব করছিলাম, প্রায় 15টা রিসার্চ ল্যাবরেটরি এবং টিচিং ল্যাবরেটরি অর্গানাইজ করেছিলেন ওই পিরিয়ডের মধ্যে। এবং সেগুলোর স্ট্যান্ডার্ড ভারতবর্ষে অন্য কোনো, ইভেন আমি ক্যালকাটা ইউনিভার্সিটির ছাত্র নিজে, বিকাশও তাই, আমরা ক্যালকাটা ইউনিভার্সিটিতে ওরকম তখন পাইনি। আমি জাস্ট একটা উদাহরণ হিসেবে বলছি। তা এই সবগুলো ডিটেলস তো বলে কোনো কি অর্থ, বরং আমি তার ওই স্প্লেন্ডারের দিক, তার বৈশিষ্ট্যের কী কী দিক, এরকম 2-4টে মন্তব্য করেই আমার বক্তব্য শেষ করব। এবং সে মন্তব্য মানে আমার অভিজ্ঞতা না, সেই মন্তব্য তার লেখা এবং তার সেই সম্পর্কে যা বলা তার থেকে করি চারটে পাঁচটে মন্তব্য করব। আমার প্রথম কমেন্ট সেটা হচ্ছে অ্যাবাউট নেচার অফ নলেজ। নলেজ বলতে শ্যামাদাস বাবু কী বুঝতেন তিনি নিজে লিখেছেন, উই লিভ ইন এ চেঞ্জিং ওয়ার্ল্ড and we must keep an open mind wherewith to meet those changing conditions. Only one thing is unchangeable, and that is the knowledge that conditions constantly change and that our progress depends on recognizing them. এটা হচ্ছে তার নলেজ সম্পর্কে তার যে বক্তব্য সেটা। দ্বিতীয় মন্তব্য যেটা আমি করতে চাইছি সেটা হচ্ছে ইনস্টিটিউশন সম্পর্কে কি ভাবতেন, যে ইনস্টিটিউশন একটা ইউনিভার্সিটি কি হবে। উনি খুব ক্ষুব্ধ হয়ে লিখেছেন, ইজ ইউর ইউনিভার্সিটি অলওয়েজ টু বি এ প্রিপারেটরি স্কুল ফর ফরেন ইউনিভার্সিটিজ হুইচ হ্যাভ এ ওয়ার্ল্ড ক্লাস, হোয়াই আর ইউ নট এ ওয়ার্ল্ড ক্লাস। এটা হচ্ছে যে মানুষটা চেষ্টা করছেন যে শুধুমাত্র আমরা ছাত্রদের এখানে তৈরি করব তারপরে পিএইচডি করতে বিদেশে চলে যাবে না, এমন ইউনিভার্সিটি তৈরি করব যেখানে লোকে রিসার্চ করতে আসবে। এটা হচ্ছে তার ইউনিভার্সিটি বা ইনস্টিটিউশন সম্পর্কে তার ধারণা। এবার রিসার্চ সম্পর্কে তার কি ধারণা সেটা আমি একটু বলি। উনি বলছেন, উনি সুপারভাইজারকে টিচার হিসেবেই সবসময় বলেছেন। তা you must first have as the teacher one who after long seeking has found something, who has seized boldly as it were the thorns that beset his own path in the hope of making a little easier for those who should come after him. এটা হচ্ছে তার একজন রিসার্চার কি করবে, সে এমন একটা জিনিস তৈরি করবে যে তার পরে যারা আসবে তাদের একটু সুবিধা হবে সেই পথে যাওয়ার জন্যে। আমি তো জানি না কেউ রিসার্চ সম্পর্কে এই ধরনের কথা বলা সম্ভব। এখানেই শেষ করছেন না, পরের স্টেজটা আরও সাংঘাতিক। সেটা হচ্ছে he who enhances the value of life and work by drawing others into the great vortex of the struggle for truth. তার কাছে রিসার্চ মানে স্ট্রাগল ফর ট্রুথ, এবং সেই স্ট্রাগলটা হচ্ছে ভর্টেক্স। এই যে চিন্তা বা যে প্রকাশ, এটা আমি কিন্তু খুব বেশি দেখিনি, বিকাশ হয়তো কিছু দেখে থাকতে পারে, বলতে পারে, আমার দেখা নেই। এবং তারপরে বলছেন, দিস ইজ দ্য ম্যান হু ক্যান অ্যালোন কিন্ডল এনথুজিয়াজম ইন হিজ ডিসাইপলস। যিনি এমন রিসার্চার, তিনিই তার ছাত্রছাত্রীদের মধ্যে অনুপ্রেরণা জাগাতে পারেন। বিকজ এ ক্যান্ডেল ক্যান অনলি বি লাইটেড ফ্রম অ্যানাদার বার্নিং ক্যান্ডেল। He considered a researcher as a burning candle who is constantly burning. তো আমাদের নিজের লেখার থেকে এ তো হলো যিনি রিসার্চ করছেন, গাইড, টিচার। হোয়াট অ্যাবাউট দ্য স্টুডেন্ট? তার স্টুডেন্ট সম্পর্কে মন্তব্য আরও চ্যালেঞ্জিং, সেটা শুনুন এবার। As regards the qualification of true students, he is one who comes seeking at all costs to know. সেই ছাত্রই ছাত্র যে জানার জন্য আসছে, এবং it is knowledge itself and not accessories of knowledge. I repeat, it is knowledge itself and not accessories of knowledge. What are the accessories of knowledge? Fame, comfort, power, that should be all in all to him, not accessories of knowledge. যেমন তার ডিমান্ড ফর রিসার্চার, সুপারভাইজার, তার একই চ্যালেঞ্জিং ডিমান্ড ফর দ্য স্টুডেন্টস। ভাবা যায় না। এবার শেষ করি। যে রিসার্চের জন্যে, গুড রিসার্চের জন্য অ্যান এক্সপেরিমেন্টার, পার্টিকুলারলি অ্যান এক্সপেরিমেন্টার, তার কোয়ালিটিস। The first is the possession of a great imaginative faculty. For the real laboratory is one's own mind, where every experiment has at first to be visualized in all its details. Aimless experimentation without vision is futile. This is what is expected of an experimenter. Then again, he qualifies it. Thinking is, however, only the preliminary step. One has next to compare his thoughts with the facts to be discovered by following surer path on right scientific demonstration. Imagination, if not properly restrained, invariably leads to wild speculation and is survive all intellectual sanity. This is the demand from an experimenter. Finally, two other conditions for the successful prosecution of research. First of all, this is a bit a controversial statement, but still I believe this is very interesting. For the successful prosecution of research are the facilities of a well-equipped laboratory and the invention and construction of indigenous new instruments of extreme delicacy and precision. নিজের হাতে ইনস্ট্রুমেন্ট বানাতে হবে, ওয়েল ইকুইপড ল্যাবরেটরি থাকা সত্ত্বেও। The closed doors will then only be opened, and seemingly impossible will then become possible and attainable. As far as possible, one should not depend on imported sophisticated instruments which the worker rarely knows how to handle properly. This may not be acceptable to all. This is how this man with splendor reacts. আমার কোনো ওর সম্পর্কে আর ডিটেলসে বলার কিছু নেই। এই অভিজ্ঞতাগুলো যদি আমরা সবাই শেয়ার করি, আগামী দিনের রিসার্চাররা, ছাত্ররা, আমার মনে হয় আমরা শ্যামাদাসবাবুর প্রতি সঠিক শ্রদ্ধা দেখাতে পারবো। এবং আমি আবার শেষ করি এই বলে যে আজকে এশিয়াটিক সোসাইটি, আমাদের প্রেসিডেন্ট, সেক্রেটারিরা যেভাবে উদ্যোগ নিয়ে এর আয়োজন করেছেন, এবং করেছেন বলেই আমি এটা শ্যামাদাসবাবু লিখেছেন 1987-এ। অকেশনটাও বলে দিই যে কী অকেশনে এই সব কথাগুলো উনি লিখেছেন। অকেশনটা ছিল একটা কনফারেন্স করা হয়েছিল যে পোস্ট গ্রাজুয়েট লেভেলে ফিজিক্সের যেসব এক্সপেরিমেন্ট করা হয় সেগুলো নিয়ে ভাবনা চিন্তা করা দরকার। এবং সেই ভাবনা চিন্তা করতে গিয়ে, মানে শুধু যাদবপুর নয়, যাদবপুর ছাড়া যাদবপুর, কলকাতা, কল্যাণী, সব মানে পশ্চিমবঙ্গের সব বিশ্ববিদ্যালয়, আইআইটি, এদেরকে নিয়ে একটা মানে আলোচনা সভা হয় এবং সেই প্রসিডিংসটাও ফিজিক্স টিচারে 1987-এ পাবলিশড হয় এবং সেখানে শ্যামাদাসবাবুকে ডাকা হয়েছিল যে এই সম্পর্কে বলার জন্যে। উনি যে যে জিনিস বলেছিলেন তার থেকে আমি এখান থেকে তুলে আপনাদের সামনে রাখলাম। নমস্কার।
প্রথমেই ধন্যবাদ অশোকনাথ বসু মহাশয়কে। এই যে অভিনব উপায় উদ্ভাবন, এত সংক্ষিপ্তভাবে এত বৃহত্তর জগৎকে যে তুলে ধরা যায়, এটাও তো একটা শিক্ষা। আমাদের পরবর্তী যে কর্মসূচি ঘোষিত আছে সেটাতে যাবার আগে আমাদের মাঝে উপস্থিত আছেন প্রেসিডেন্সি বিশ্ববিদ্যালয়ের উপাচার্য শ্রীমতী অনুরাধা লোহিয়া মহাশয়া। আমরা আমাদের পক্ষ থেকে ওকে অনুরোধ করছি যদি সংক্ষিপ্তভাবে মঞ্চে এসে কিছু বলেন। আমি সকলের তরফ থেকে আপনাকে না না এই যে আমাদের ফোল্ডার ব্যাগ।
নমস্কার। আজকের অনুষ্ঠানের জন্য আপনাদের সবাইকে অনেক অনেক অভিনন্দন। আমি এই সম্পর্কে প্রফেসর বিকাশ সিনহার কাছ থেকে জানতে পারলাম, তাই জন্য আমি আজকে এখানে উপস্থিত। আমি তো ফিজিক্সের লোক না, কিন্তু বেকার বিল্ডিংয়ে যেখানে উনি পড়িয়েছেন ওখানে পড়েছেন, আমিও ওখানেই ছাত্রী ছিলাম। আর এই যে লিনিয়েজ, যে উনি যার ছাত্র ছিলেন ডিএম বোসের, আর ডিএম বোসের সাথে উনি প্রেসিডেন্সি কলেজ থেকে বোস ইনস্টিটিউট যান, এই পথ আমরা অনেকেই প্রিভিলেজ ছিলাম যে আমরাও প্রেসিডেন্সি কলেজ থেকে বোস ইনস্টিটিউট গিয়েছিলাম। আর এটা আমার নিজের সৌভাগ্য যে আমি ফিজিওলজি অনার্স পড়ে বোস ইনস্টিটিউটে রিসার্চ প্রথমে পিএইচডি করতে যাই, কিন্তু ওখান থেকে পরে আইআইসিবি চলে যাই। কিন্তু পরের চাকরি করার সময় I became an assistant professor in Bosch Institute. So this path is very special. আর আমরা যারা যারা এই সৌভাগ্যটা পেয়েছি, we feel very blessed. We were indeed privileged to go through this path. Because এই যে পাথটা তখনকার দিনে প্রেসিডেন্সি কলেজে অ্যাডমিশন পাওয়া, পড়াশোনা করে একটা ডিগ্রি নিয়ে বেরোনো, সেটা আর আজকের মতন দিন না, যেখানে আজকে অনেক অপশন, অনেক কলেজ, অনেক ইউনিভার্সিটি আছে। তখন এটা স্পেশাল ছিল, ভীষণ কম্পিটিটিভ ছিল, আর ওদের সময় আরও বেশি। আর তখন যে কোয়ালিটি এডুকেশন আর রিসার্চ ওরা করতে পেরেছে আন্ডার আ লট অফ ডিফিকাল্টিজ অ্যান্ড উইদাউট এনি প্রপার সাপোর্ট অ্যান্ড ইনফ্রাস্ট্রাকচার, এটাই অসাধারণ। আর যে কথাটা, লাস্ট কথাটা প্রফেসর বসু বললেন যে ওনার যেরকম একটা ধারণা ছিল যে ভালো রিসার্চ করলেও, ভালো ল্যাবরেটরি থাকলেও নিজের হাতে ইনস্ট্রুমেন্ট বানাবে, এই কথাটা আমরাও কিন্তু ছাত্র জীবনে বোস ইনস্টিটিউটে আমাদের মাস্টারমশাই থেকে পেয়েছি। অ্যান্ড বোস ইনস্টিটিউট ওয়াজ স্পেশাল যে ওদের নিজেদের একটা ইঞ্জিনিয়ারিং অ্যান্ড ওয়ার্কশপ ডিপার্টমেন্ট ছিল। আমি প্রথম যখন পোস্টডক করতে যাই আমেরিকাতে, আই ওয়াজ সারপ্রাইজড যে বড় বড় ইউনিভার্সিটিতে এরকম নিজস্ব ওয়ার্কশপ ছিল না, যে ছোট ছোট অ্যাপারেটাস নিজে তৈরি করতো। আমরা নিজেদের নিডসের মতন, হয়তো খুব সফিস্টিকেটেড দেখতে হতো না, একটু ক্লামজি হতো, কিন্তু কাজটা নিজের রিসার্চের মতন করতে পারতাম, ওরম ইনস্ট্রুমেন্ট বানাতে পারতাম। এই প্রেরণাটা আমরা শ্যামাদাস চ্যাটার্জি, ডিএম বোস, জগদীশ বোস, উনি তো সব কিছুই নিজের হাতের তৈরি, নিজের হাতের ইনস্ট্রুমেন্ট তৈরি করে নিজের যে রিসার্চটা করলেন, সেই প্রেরণা তো আর কেউ আমাদেরকে দিতেই পারবে না ওই লেভেলে। আপনারা সবাই অনেক গুণীজন স্টেজে যারা ফিজিসিস্ট বসে আছেন, এশিয়াটিক সোসাইটির লোকেরা বসে আছেন, আপনাদের সবাইকে আমার প্রণাম আর অভিনন্দন। অডিয়েন্সেও আপনারা সবাই ফিজিসিস্ট স্কলার্স যারা আছেন, I greet you on this very special occasion যে আপনারা এখানে অর্গানাইজ করেছেন। আর এটা সত্যি, it's a very reassuring thing that in Calcutta we remember, we always go back to our roots, to our teachers, to our research যাদের থেকে inspiration পেয়েছি, and this is what keeps the tradition alive. Even the Asiatic Society has shown us the path of how to keep centuries old traditions alive. অনেক বছর আগে এসেছিলাম, মাঝখানে আসতে পারিনি অনেক কাজের জন্য, কিন্তু এসে পুরো সব পুরনো দিনের মেমোরিজ আবার ফিরে এলো। থ্যাংক ইউ ভেরি মাচ ফর গিভিং মি দিস অপরচুনিটি। এই স্টেজে বলার মতন আমার আর তো কিছু নেই। থ্যাংক ইউ, নমস্কার।
ম্যাডামকে অনেক ধন্যবাদ, উনি এসছেন এবং আমাদের সামনে বলেছেন। এখন আমাদের সভাপতির ভাষণ দেবেন এশিয়াটিক সোসাইটির সভাপতি অধ্যাপক স্বপন কুমার প্রামাণিক।
মাননীয় অধ্যাপক অশোকনাথ বসু, যার সাথে আমার দীর্ঘদিনের পরিচয়, মাননীয় অধ্যাপক দীপক ঘোষ, ডক্টর এস.বি. চক্রবর্তী, জেনারেল সেক্রেটারি, ডক্টর সুজিত কুমার দাস, ট্রেজারার, সামনে রয়েছেন প্রথিতযশা বৈজ্ঞানিক অধ্যাপক বিকাশ সিনহা, অধ্যাপিকা অনুরাধা লোহিয়া, যার এশিয়াটিক সোসাইটি সম্বন্ধে প্রশংসা বাক্য আমাদের উদ্বুদ্ধ করেছে, এবং সামনে উপবিষ্ট সম্মানিত কাউন্সিল সদস্যবৃন্দ এবং অধ্যাপক শ্যামাদাস চ্যাটার্জির অনুরাগী ছাত্রছাত্রী গবেষকবৃন্দ। সত্যি কথা বলতে কি, অধ্যাপক শ্যামাদাস চ্যাটার্জি সম্বন্ধে আমি কিছুই জানতাম না। কয়েকদিন আগে আমাদের মাননীয় সাধারণ সম্পাদক বলেছেন যে এশিয়াটিক সোসাইটির উদ্যোগে অধ্যাপক দীপক ঘোষের অনুলিখিত যে একটি প্রকাশনা বক্রেশ্বর উপাখ্যান, সেটি আন্তর্জাতিক বইমেলাতে প্রকাশিত হয়। সেই অনুষ্ঠানে আমি উপস্থিত ছিলাম। বইটির যে টাইটেল, সেটাও আমাকে খুব বেশি নাড়াচাড়া দেয়নি। ভেবেছিলাম যে কিছু একটা মিথিক্যাল কিছু একটা বিষয়, কিন্তু সেটা পড়ে ভেতরে গিয়ে ঢুকে অধ্যাপক শ্যামাদাস চ্যাটার্জির গবেষণার যে বিশ্ব, সবটা যে বুঝতে পেরেছি তা না, কিন্তু আমি চমকে গেছিলাম। এরকম একজন বৈজ্ঞানিক আমাদের এখানে কাজ করেছেন 40-এর দশকে, 50-এর দশকে, 60-এর দশকে, এবং রিটায়ার করার পরেও তিনি প্রাণবন্ত ছিলেন, বিভিন্ন ক্ষেত্রে এক্সপেরিমেন্ট করেছেন, গবেষণার ফলের ওপর তিনি লিখেছেন, এবং তার গবেষণার ক্ষেত্র যেটা, সেটাও যে ঠিক মামুলি গবেষণার ক্ষেত্র তা নয়। অধ্যাপক বসু খুব চমৎকারভাবে এবং প্রাঞ্জলভাবে বলেছেন যে গবেষণার উদ্দেশ্য উনি কোট করেছেন শ্যামাদাস চ্যাটার্জির বক্তব্য থেকে, এনহ্যান্সিং দ্য ভ্যালু অফ লাইফ অ্যান্ড ওয়ার্ল্ড। কজন বৈজ্ঞানিক তার গবেষণার ক্ষেত্র হিসাবে, লক্ষ্য হিসাবে এই রকম একটা বিষয়, এত বড় একটা বিষয় তার মাথায় রাখতে পারেন? এনহ্যান্সিং দ্য ভ্যালু অফ দ্য লাইফ অ্যান্ড দ্য ওয়ার্ল্ড। গবেষক এবং অধ্যাপক তাদের মধ্যে যে জীবন্ত প্রাঞ্জল সম্পর্ক, সেই সম্পর্ক সম্বন্ধেও অধ্যাপক বসু তার কিনোট অ্যাড্রেসে বলেছেন। বস্তুতপক্ষে আমি যদি আরেকটু ওয়াইডেন করি বিষয়টাকে, একটু বিস্তৃত করি, অধ্যাপক শ্যামাদাস চ্যাটার্জি তার বাসস্থান বালিগঞ্জে, সেটা তিনি দান করেছেন এশিয়াটিক সোসাইটিকে। এত কিছু জায়গা থাকতে এশিয়াটিক সোসাইটিতে কেন তিনি দিলেন? এশিয়াটিক সোসাইটির যে ম্যান্ডেট স্যার উইলিয়াম জোন্স লিপিবদ্ধ করেছিলেন আজ থেকে প্রায় 250 বছর আগে, সেটা হচ্ছে whatever is performed by man and produced by nature, এর সমস্ত কিছু নিয়ে এশিয়াটিক সোসাইটি তার গবেষণা করবে। এই যে প্রডিউসড বাই নেচার অ্যান্ড পারফর্মড বাই ম্যান, তার মধ্যে বিজ্ঞানের যে বহুধা বিস্তৃত কর্মক্ষেত্র, গবেষণা ক্ষেত্র, সেগুলো কিন্তু খুব গুরুত্বপূর্ণ অংশ। এবং আমার মনে হয় অধ্যাপক শ্যামাদাস চ্যাটার্জি তার বাসস্থানটি এশিয়াটিক সোসাইটিকে দেওয়ার পেছনে এটাই হয়তো মূল কারণ ছিল, যে এই ধরনের আনকনভেনশনাল রিসার্চ ওয়ার্ক, এই ধরনের একটা প্রতিষ্ঠান এশিয়াটিক সোসাইটি ক্লোজ কোলাবোরেশনে যদি হয়, তাহলে তার জীবনের উদ্দেশ্য সফল হবে বলে তিনি মনে করেছিলেন। বিভিন্ন কারণে হয়তো আমাদের এশিয়াটিক সোসাইটির পরিচালন ব্যবস্থায় দুর্বলতা অথবা ঘাটতির কারণে সেই বাড়িটিকে এখনও পর্যন্ত আমরা সঠিকভাবে ব্যবহার করতে পারিনি। আমি বলবো, আমি সেদিন অশোকনাথ বসু মহাশয়কে বলছিলাম যে এই সেমিনারের মাধ্যমে যদি তার এই উদ্দেশ্য আদর্শকে সফল করার জন্য এশিয়াটিক সোসাইটি একটা কোলাবোরেটিভ ইনস্টিটিউট হিসাবে, যাদবপুর ইউনিভার্সিটি হোক বা অন্য কিছু হোক, তাদের সাথে কাজ করে একটি গবেষণাগার সেখানে স্থাপন করতে পারেন, আমাদের সদস্যদের মধ্যে, এশিয়াটিক সোসাইটির সদস্যদের মধ্যে অনেক বিজ্ঞান মনস্ক গবেষক আছেন, তারা তাদের কাজকর্ম করার জন্য একটা উপযুক্ত ক্ষেত্র পাবেন, যেটা শুধুমাত্র এক্সপেরিমেন্টাল সায়েন্স হবে না, অথবা হয়তো প্রধানত এক্সপেরিমেন্টাল সায়েন্স হবে না, কিন্তু যেটা সাধারণভাবে বলা যায় ফিলসফি অফ সায়েন্স, সেই সংক্রান্ত যে ধরনের গবেষণা আমরা সেখানে পরিচালনা করতে পারি। এবং তা যদি করতে পারি, তাহলে আজকের এই সেমিনার, আলোচনা চক্র, তার উদ্দেশ্য সফল হবে। এবং সেখানে যদি আমরা ইয়ং রিসার্চার যারা আছেন, তরুণ গবেষক যারা আছেন, তাদের যদি উদ্বুদ্ধ করতে পারি, তাদের যোগাযোগের প্রতিষ্ঠান হিসাবে আমরা কাজ করতে পারি, তাহলে অধ্যাপক শ্যামাদাস চ্যাটার্জি তার জীবনব্যাপী যে সাধনা করেছেন তাকে হয়তো খানিকটা সম্মান আমরা দিতে পারবো। এই কটা কথা বলে আপনাদের সবাইকে ধন্যবাদ জানিয়ে আমার বক্তব্য শেষ করছি। নমস্কার।
আমাদের উদ্বোধনী অনুষ্ঠানের শেষ পর্ব ধন্যবাদ জ্ঞাপন। ধন্যবাদ জানাবেন এশিয়াটিক সোসাইটির মাননীয় ট্রেজারার ডক্টর সুজিত কুমার দাস।
Respected President, Professor Shapan Kumar Pramanik, respected former Vice Chancellor, Professor Ashoknath Bosu, Professor Deepak Ghosh, our General Secretary, Dr. Satyabrat Chakraborty, renowned scientist, Professor Vikas Sinha, respected Vice Chancellor, Presidency College, Professor Anuradha Lohia, our council members, research scholars, and everyone present in the meeting, a very good afternoon to you all. Now, this is my proud privilege to say vote of thanks, and we are at the close of this inaugural session. First of all, I must express our vote of thanks to the Biren Rai Research Laboratory for Archaeological Dating and School of Studies in Environmental Radiation and Archaeological Science to extend their cooperation to organize this seminar, international seminar on Professor Syamadas Chatterjee, a physicist of many splendor. We just have heard that this name was given by, was coined by Professor Vikas Sinha, a renowned scientist. I must express our vote of thanks to our employees who worked hard to organize this seminar. And finally, Professor Syamadas Chatterjee, we do not know we know very little about his works. What we know that he donated his residential house to the Asiatic Society, which was used by Asiatic Society for their guest houses. And we heard that in the first floor of the building, some scientific instruments and books are there. And that also was not in a very good way. Organization was not also very good. And now this building's condition is very bad. Now this occasion will definitely give us a position to rethink the situation and set up the building and his donation and this building for a good use, for a better use of science and technology. I was Professor Ashoknath Bosu, as he mentioned, the keyword, the way Professor Syamadas Chatterjee was thinking about research, the struggle for truth, the quest for truth. So we should follow this. This is a very little word, but has a very good significance. The research must be a quest for truth. With these few words, I express my thanks to you, and thank you very much. Thank you.
Distinguished guests and friends, since there is no break today in this afternoon program, we will straight away enter into our first academic session, where the keynote address will be delivered by Professor Vikas Sinha. There will be two plenary lectures by Professor Nabakumar Mondal and Professor Debashish Ghosh. This is the first session. The second session, plenary lecture by Professor Rajkumar Rai Chaudhuri, plenary lecture by Professor Sugato Hajra, plenary lecture by Professor Joyashree Rai. I think she would participate online from Bangkok. Session 3 and the penultimate session, plenary lecture by Professor Maniklal Majhi, plenary lecture by Professor Orgho Deb, plenary lecture by Professor Kalyan Kumar Chattopadhyay. After this, we will have 15 minutes kind of a valediction over the whole session, and then we end up today's program. So, may I now request our present occupiers of the dais to please take their seat in the audience, and which will be replaced by the speakers of the next session. I'll request Professor Vikas Sinha, sir, please come. Professor Navakumar Mondol. Professor Navakumar Mondol, sir, please come. Professor Debashish Ghosh, sir, is already here. And this session will be chaired by Professor Anuradha Lohia. Madam. Sir. Madam, before we begin...
You've already given me one.
Yeah.
Thank you.
No, madam. So straight away, we request Professor Vikas Sinha.
Professor Chakraborty, Professor Anuradha Lohia, my good friend, my colleague for a long time, Professor Navamondol of Tata Institute of Fundamental Research, and my colleague for a very long time, Professor Debashish Ghosh, all other dignitaries, excellent speakers previously, and ladies and gentlemen. I'm very glad that on an afternoon like this, where the sun is scorching outside, there is at least some interest in an old man who the world has forgotten. Not that Syamadas Chatterjee wanted the attention of the world. My friend Ashok Basu described his other qualities, his deep insight, and about education, research, studentship, etc. But I would add one more, that he was a rishi of a man. Rishi in the sense he had hardly any interest in earthly possessions. And I have seen that and experienced in my own eyes and ears. But most important, he never wanted anything back from his contribution to his research. And that is quite remarkable in today's spectra. Another point before I go to the main text of my talk, with what Professor Basu said, he looks, as you can see from the picture, which you have seen again and again, as a very simple man, a simple, old-fashioned, Swadeshi, Bhadralok Bangali. And you notice how he puts his kocha in his pocket. And he doesn't wear kurta pajama or Punjabi, amader bhashaয়. He wears a typical Bengali Buddhavitter je khash shirt, full shirt, সেইটি. And third thing I want to say, because there are some young people, উনি কিন্তু চটি পরে চাটপাট করে বেড়াতেন না. He had that discipline right from the beginning. His student, Devashish, tells me, whenever he was out of his house, he used to wear palm shoe. Now, আজকাল যে একটা হয়েছে, কথায় কথায় চটি পরে ঘুরে বেড়ালো, আর চটির একটা বিচিত্র শব্দ বেরোয় যখন হাঁটে মানুষ, সেটা আবার গা জ্বলে যায়. কোনো সময় জ্ঞান নেই, স্থান কাল জ্ঞান নেই, চটি পরে চলেছেন বাবাজি. এই যে দেখি আজকাল ফ্যাশন, ক্যাজুয়ালনেস, which is borrowed from, of course, outer world, outside world. So Syamadas Babu is a unique person. And having come to contact with him very intimately, I have found it a very attractive personality. And just a few things I mentioned, let it be. He's a perpetual mystery to me. First slide, please. In Presidency College, when I used to know that, and I made a point to invite my friend and colleague, Professor Anuradha Lohia, and she is not a really hoity-toity Vice Chancellor type. She really said, yes, I will come. And lots of Vice Chancellors say, yeah, I will come. But I'm very grateful to Anuradha Lohia. And then he somehow thought he will do philosophy honors. You can imagine he had a bent of philosophy in his personality. And it was possible those days to shift one to the other. The turning point in his life came, as it happens quite often, that Jagadish Chandra Bose, while he was creating this fantastic apparatus, which Ashok said in a different way, by lungi-wala, naked body, mysteries of Howrah, very accurate workmanship, and that amazed Syamadas Chatterjee, and he wanted to do experimental physics. The next, probably the most important breakthrough experiments of Syamadas Chatterjee is, as mentioned by Deepak Babu, is a spontaneous fission. At that time, there was a professor, Niraj Sen, head of the Department of Mathematics, Calcutta, who wanted his radio set to be repaired. And those days, I don't think there was around the corner shop to do that. And young Chatterjee helped him to get the radio set going, with the condition that his mathematical expertise would be available for him. Soon Chatterjee worked out the half-life of spontaneous fission, as was mentioned. It was about 1 million years. Niraj Sen actually helped him to calculate the mathematical details, whatever there was. And it was Satyendra Bose who egged him on with all kinds of ideas on the process of discovering spontaneous fission in India and first time in the world. Let's get that straight. D.M. Bose, after returning from Darjeeling, however, forced young Syamadas to withdraw the paper since the famous Shahabs, Niels Bohr and John Wheeler, theoretically estimated the half-life to be about 22 years. Now, let me emphasize it's a theoretical estimate and not experimental. Well, quite a lot of people here are physicists, and I consider rather half physicist. Physics is different from other subjects to the extent no meaning of physics is there if you don't experimentally verify. Now, I don't know what went to D.M. Bose's head. I'm sorry I didn't examine his head. Didn't have the audacity, neither I was born. But he preferred to believe Niels Bohr and John Wheeler theoretical results.
Because this is a lesson for our vice chancellors and directors.
D.M. Bose clearly had more confidence on a theoretical estimate of sahibs than the ingenious experiment of a desi young lad. And then I think standing here in this ancient monument of the Theological Society, I feel desperately sad. And traces of that, ladies and gentlemen, still goes on. Oh, he's fantastic. He has done something at Princeton. But the same fellow has been done in Calcutta, no good. He's still there in our head after 70 years of independence. I think you will agree quietly, not publicly. This is the Presidency College those days, look at those guys. And this is Prashant Chandra Mahanalesh and his wife, dear wife, and Dr. who? I'm sorry? Right. Visiting. That's the ground floor of Presidency College. And this is the Presidency College on the pad that Anuradha supplies us when you go for the board meeting. It becomes very handy. Now let's go to the mainstream of what? If somebody can give me a chair here, I'll be very happy.
You can take the side shift.
Yeah.
And also you don't.
You see, helium is used, good evening, used quite extensively all across the world. And you may wonder yourself, can you hear me? A shirt and a dhoti which is not kojal, coming into YC, very popular, over the yacht club, therefore. And Shelta went down to the sea beach and welcomed him to hear his point of view. It's a different zone. It's not mechanical, except I'm told through Ramanatha that was a great respect for Ramanatha. And they discussed. And Setna took action very quickly. To the extent, Devashish Lord knows, I think I'll talk about it probably, yes. GECC at that time was just coming up, and it's the whole plan or program of helium exploration should be shifted to GECC. And I was the first person ever from outside world to go to Bokreshwar and Tamil to see what magic nature played for centuries and so on. And that stung me, because what are we doing so far? But you see, Sahab didn't show us the Bokreshwar. No means war, no any Johnny from abroad showed us the helium source. But then both of Syamadas Chatterjee found it, and nobody cared what they had to say. It was politics, or sociology, if you like, at that time. Bokreshwar Tatli. So he comes into it. And I got a great help from DJ Vidya. I must say right here, to acknowledge the great help of Devashish Ghosh. We had great fun at that time, we were quite young. And this staying place was very rudimentary. And in fact, there was nothing very much to depend on. Your food, your shelter is very meager. So nobody complained. Mask we thoroughly enjoyed ourselves and found out that there is a large quantity of helium. These are the sources of helium. Kutalam is a natural blast field. When he went, tried, for ONGC was not too keen to get it. Essentially, the Raj Mahal volcanic belt on Tatui and there on the eastern, you know where Tatui is, near Shankariketi. Huge amount, you see. Another picture, that's the Agni Kundu, temperature is 80 degrees. And funny enough, although it's 80 degrees, the rice grains don't get boiled. And naturally there is a natural sort of peculiarity. So, as usual in our beloved country, the temples have come out. The pujaris at the temple have the heat day, and you had a hard time to get into the picture, scenario. And then is Syamadas Chatterjee measuring radon, electroscope in operational lab, 10 feet by 10 feet. None of these great air conditioned labs those days. With thousands of computers, nobody knows what to do with it. You ask the young boy, what are you doing with the computer? You are computing, you can't see that. You have to know what is the purpose of it. Those days there was enough attention, enough enthusiasm to do such a thing. This is the letter, these letters, the famous letter, 22nd January 1974, to Nurul Hasan. If you don't mind, I'd like to read it out. Very emotional. The evening of life is almost invariably a satire on the eager, brilliant hopes of a dawning manhood. It's in both writing. And so it is refreshing to be remembered and honored by friends and pupils alike at the fat end of one's career. Life seems to be a perpetual round of anxieties and the struggle for existence, sometimes not to be able to quench intellectual ardor. Incidentally, I'm rather anxious for a long-term renewal of the helium collection research scheme, which is on the threshold of production on a semi-commercial scale in 1974. You saw that. And he's theoretical physicist, father of both Einstein statistics. But he saw that something is very happening there. Already Bhabha Atomic Research Center has been in touch with us for the wholesale consumption of a purified helium. I therefore suggest the scheme may profitably be extended for a further period of 5 years. And you still believe. Nobody believes that. I mean, I have to get some Johnny from America who is totally stupid to brainwash him to say that there's something happening there, that people believe. I'm so tired and sick the last 20 years trying to argue with the government that it's a gold mine. Well, unfortunately, it's in both died soon. So this is an important picture. This is actually a tsunami meeting. Tsunami incidents happened in sometime in 2005, March 1 and 2. You remember tsunami? With absolute havoc in southern part of India. The tsunami is a very deep problem inside the sea. I call it not earthquake, but seaquake. It goes well below the ocean. If you look at the diagram carefully, this is what the gas comes out. Along with helium, there is also the so-called deuterium here, D2. Now, I don't know how many scientists are here, but how would it get D2? The question has bothered us for a long time. But the D2 could come from anywhere. But we discuss among ourselves, there is always an element of heavy water in the sea, but that's in compound, D2O, but not D2 plane. D2 plane can be there in fusion. This is the deuterium-tritium target with neutron and deuterium sitting there on the left. So I don't want to say much because I will be alive before I go home. Such an incredible demand of assertion that something is going on underneath the planet Earth, which is yet to be discovered properly deep down. But from there the tsunami managed to extract the helium. This is the Tantui region, helium ppm. The lowest in ground is about 5 or 6. It goes up to 1,000, 1,200. And Bokrishwar, same high but not that high. This is the belt all along the Raj Mahal earthquake belt. And this is where we can explore and go on and discover many sources of helium. I want to say something here and finish it. This you see, right, number 13, ppm 1058 is coming, 1064. It's a huge number. And we have to harness it. Fortunately, the present chairman of the Atomic Energy Commission has agreed to involve other companies within the atomic energy to explore it in a big way. Because now they're really being pushed with escalating price again and again. It's a three-dimensional diagram. You see the spikes. The spikes actually is the helium. Similarly, the contours, the beautiful modern painting, like the beak of a bird, but it's the beak of the helium. These are numbers to show that we have enough helium to cater for the need of India and much more than that. Now you may think today that they are talking nonsense, and excuse the French word, bullshit probably, impress us. It's up to you to believe me or not, but we are not going to let down. We are going to work very, very hard to push it before it's too late for us in age. The density of helium, the last one, is also noted in the agenda. You see the helium-3 to helium-4 ratio. It's very simple arithmetic, not even physics or geology. Goes up, so-called resource of helium, especially earthquake time. So helium-3, helium-4 ratio goes up, which means the density of total helium goes down, and that's a sure sign excess helium-3. Kaiton. Now what does it mean? It means probably, that I'll ask you to think before you go to sleep. The earth is produced from the sun, you all know that. Don't think about it. You watch the sun in the morning, at dawn. And when the sun produces the earth and other planets, sun atmosphere inside core of sun, enormous amount of fusion reaction going on, and there must be lots of helium, which we call primordial helium. And that primordial helium probably is still stuck inside the center of the earth, and that you are tapping. Hopefully, presumably I'm right. Why do I say that? because the amount of helium coming out from the primordial days of the earth is so much that actually to produce the radiogenic result is just simply impossible. But these are tall arguments, and if you have to prove it to the world most substantially. And I am so sure with your help, some more excitement, and such meetings in public places, it will go a long way to help us. What you see really is a part of a creation of the earth, as simple as that. And this is Rajmahal volcanic belt that we saw is the first landmark produced on earth after earth cooled down to reasonable temperature. That is, India was the first landmark production for anywhere else in the world, but you do know. So that is likely to be mother of all this so-called storehouse of these things, as I mentioned. Well, any now we have gone over 20 minutes. And thank you very much, Professor. Thank you very much indeed to give this opportunity. I hope that at least 10% of the discussion are able to understand or appreciate, and should be given to younger people much more information and excitement so they can push the project for the future generation. And I'm sure the blessing of great man Syamadas Chatterjee will help us to go forward. Thank you very much indeed. Sorry, I went up too long now.
Thank you so very much, Professor Sinha, not only for being with us in spite of all busy schedules elsewhere, but also presenting brilliant ideas, at least before the young researchers. Hopefully, we would be able to push it forward as you have expressed. Let us see. Now, plenary lecture to be delivered by Professor Navakumar Mandal.
I am probably the odd man out here because I have no connection with Kolkata, really speaking. I have never been in Calcutta except last 4 years. So Vikas probably found me the person who will be giving outsider view about what was happening in that period. So let me try to do that. So
Whatever you say, no, don't say nothing.
So the title of my talk is Syamadas Banerjee and the Cosmic Ray Research in India, because this is really linked actually, what you will see fine soon. Okay, so I'm putting in this picture because I don't have to explain this picture to you here. These are all, famous people who are from the Science College and Calcutta University in those days. But I put it only, I want to point out to two persons in this picture who has a direct link to the story that I'm going to talk about Syamadas Chatterjee. And this, of course, the first person comes here is Acharya J.C. Bose, the first experimentalist this country ever had. Okay, so this is actually, I have to talk to you, and then the other person is, it's actually not, can you turn it this way, the laptop, a little bit? Yeah, that's right. Now let me try. Yes. Okay, the other person is D.M. Bose, of course his nephew and student, both experimentalists par excellence, and this is actually the same tradition that Syamadas Chatterjee has followed himself. So just a little bit about this, we all know about J.C. Bose. He was the person who has originally built all his experiments by himself, all the instruments, and that was followed by Devendra Mohan Bose as well as by Syamadas Chatterjee. So now, a few words about.
He is not Devendra Mohan Bose. He is Syamadas Chatterjee.
No. That's my background of the screen. I know. Okay, so you will find everywhere in my screen. Okay, so Devendra Mohan Bose is the founder of Calcutta School of Cosmic Ray Physics, really speaking, and so you can see his line of this thing. He was in Presidency College in 1906. Then he went to Christ College, Cambridge, worked with two great experimentalists, J.J. Thomson and C.T.R. Wilson, C.T.R. Wilson is at that time building the cloud chamber in Cambridge. And then he came back, became the Raspberry Ghost professor, and immediately went again to Germany on a scholarship. And then he was to go there for 2 years, but because of the First World War, stayed there for 5 years, and learned a lot from the famous cosmic ray physicist Eric Wegener about operation of cloud chamber. So it is not So it is expected that he started the cloud chamber work first. And the cloud chamber, that first cloud chamber is built, is a 12-inch cloud chamber with his student, that time Subodh Kumar Ghosh. And in 1920, he was already publishing papers of great cosmic ray work and photographed the recoil tracks of radioactive nuclei using alpha emission. Earliest evidence of artificial disintegration, that is what is later on will be used in the accelerator. For the first time seen in the cloud chamber, and then published all their results in Nature. And this work got discontinued for some time, but again in the 1930s, but D.M. Bose actually restarted the cloud chamber activities along with Syamadas Chatterjee, Auraprasad De, Rajendra Lal Sengupta, and Mridanga Shekhar Sinha at Bose Institute at that time. So why I am putting this one, you see the context. There are suddenly so many students excited to do experimental science in India. Okay? And that is and you need for such experimental group, not single person. Now coming to Syamadas Chatterjee, I don't have to talk much because Vikas has already, an earlier speaker has already spoken to him. He went to BSc from Presidency College, and he was, basically, he was motivated by the lecture demonstration of J.C. Bose to continue in physics, and then he did his MSc from Calcutta University in 1932 and immediately joined D.M. Bose as a Raspberry Ghosh Fellow and then as a Taraknath Pavit Fellow at Calcutta University, and moved to Bose Institute along with D.M. Bose again in 1938. And this is the time exciting things started happening actually at the Bose Institute. And so of course, now when he came there, he also got exposed to Ranasam Ghosh, who just returned from Germany, working with Geiger-Müller there. And working with Geiger-Müller counter at Germany, he came back, and because before that, Syamadas Chatterjee was not working in cosmic rays. And as soon as it happened, he started working on cosmic rays, and he got very excited because he started immediately. He was the instrument person. He will build instrument by himself. So he started making a versatile man who quickly developed expertise in gas-based counters, Geiger-Müller counters, ion chambers, proportional counters, you name it, he will build it. And with it, he is an expert on associated electronics, gas-blowing, machine saw. You must remember this actually. This was told to me by another great person I met actually in TIFR. His name is Bimalkanti Chatterjee. And he told me that I was later on working on my electronic circuit, being a physicist, and he told me that I was telling him that I am becoming a Kalaiwala. And that was his word actually. He told me science is not done just using a pen and paper. You need Kalaiwala too. That is experimental. Okay? And that was actually will be defining the Syamadas Chatterjee, because you have to make your hands dirty. You have to build your instrument by yourself. And that is what. So first important work of Syamadas is already talking about. Spontaneous fission, I am not going to do much. He got excited in 1938. The news came that the fission, neutron bombarded fission has been already observed at that time, okay, in Germany. And then he got this news and he wanted to do himself because he has all the apparatus built himself. He has the GM counter, ionization chamber, and oscilloscope, everything is ready with him. So he immediately went out and did this experiment using the ion chamber, and he confirmed, of course, that he saw that yes, when you bring the neutron source, bombardment and neutron fission is happening. But you remove the source, he still sees the pulses coming. And that was puzzling. So what can happen? Well, there are neutrons in the cosmic rays. So they can create this fission. You cover it completely. and then immediately you'll see that it should go away. Didn't go away. So then what is happening? That was very puzzling result. And then he was talking about this, and he went to that. He has good relation all the time with S.N. Bose. So he went to Satyendra Bose, and Satyendra Bose just casually mentioned maybe it is spontaneous fission. As soon as he got this idea, he started doing a high statistic run and got a lot of data. And as you said, that he get help of an Arsen mathematician and got the decay time constant, which is coming to 10 to the power 16 years actually. But 10 to the power 16 is not the number, because as Vikas was telling us, and Bode and Wheeler has given us the number 10 to the power 21. So this is how the problem came. But anyway, he went ahead and wrote that paper and sent it for publication. Okay? Because he's an experimentalist. But then when D.M. Bose came back from Darjeeling, he found that, and he said that he was very, very, uneasy with that one, because there is a 10 to the power actually almost million times difference between this observation and what is expected. And so he said, okay, you continue more study. Actually, that is the most mistake. Actually, what I said, that you should have believed your data. As an experimentalist, your data should be supreme. You don't even distrust your data. If you don't do that one, you will do mistake, and that's what has happened. And it has happened many times to many people. So it's not. So anyway, within 2 months of that work, what happened to that one? Okay, anyway, so that he published ultimately that paper in 1944. By that time it is too late. So now, apart from fission, at Bose Institute, Syamadas worked on a variety of cosmic ray topics. During 1939-40, he took up the study of thermal neutron in atmosphere, because that was directly connected to the other work that he was doing. He was looking for the fission, and that neutron was his main background, and so you have to understand the cosmic neutron. So that's what he was doing there. Established a laboratory at Darjeeling to study distribution of atmospheric neutrons at different altitudes, actually going from all the way from the sea level to the high altitude. They studied influence of solar flare on cosmic ray intensity. See, solar flare, when it comes, they will also, because of the magnetic field of the Earth, they will disturb the local magnetic field, and then it will happen. Study the influence of solar flare. Large cosmic ray burst studies. Production and penetration, production of penetrating shower, because when that time already shower theory has come already by Homi Bhabha and Wheeler, and then he was also studying that one in experimentally. For example, he was looking into the penetrating shower, those through the lead, which is going through the lead and iron, and so on. So all cosmic ray type, using all his work, he ultimately got his DSc from Calcutta University in 1945. Then he moved to Ottawa on a scholarship. And that was actually 49 to 51, he was in Canada. And here, again, he was a skilled experimentalist by that time, an instrument builder already. His fame is already there. So he started building new kind of instrument there. And then also did a lot of other work. Again, ionizing power of cosmic rays at sea level. I'll tell you, this is actually connected to what we call today delta rays. High energy electrons emitted by when a moving particle is going in cosmic rays. And what is the fraction of the time the delta rays are produced? You have to understand that. So he built an instrument to do that. Diurnal variation of cosmic rays over the whole day, how it is varying at sea level. Possibility of spontaneous fission in other nuclei. Already uranium has already been seen. What about the other materials? And there is already in the literature, people are claiming that they have seen spontaneous fission in other materials, whether that is correct or not. Neutron emission in reaction induced by Deutschland. So on, so many works that he did in just 2 years. And then instrument build development, circular GM counter. This is actually a marvelous design. I'll tell you why. Because just wait for this picture here. Here is a circular, you have seen, anybody of you GM counter, it's just a cylindrical tube. And what is the problem with that? You keep a source here. You have a small solid angle there. So if you put a circular GM counter, you put your source in the middle, you get immediately a large solid angle. So your counting will goes on by almost many-fold. So this is, and if you are doing low background, then this is the apparatus used for spontaneous fission in samarium, for example. It's a beautiful experiment. You put the, a neutron counter boron field neutron counter at the middle and put the samarium all around, stick, or into the other way. Put all these, boron counters all around and put this samarium stick in the middle, and you count that one. And he actually proved that the earlier literature that has come is wrong, this result. So now back home in Calcutta, in 1951 to 55, now he has moved from Bose Institute to Science College as a lecturer there. 1952, Syamadas joined University College of Science, Calcutta University as a lecturer. Set up first radiocarbon dating laboratory at the country in 1954. There are two aspects to that setup. There are other experts. One is the converting the sample into carbon dioxide, its purification, etc., because ultimately you have to count in your counter. And second, of course, the fabrication of gas counting system using high pressure gas proportional counter. The second one is already, by that time is an expert. He doesn't need any help. But he needed some help here. And in fact, I didn't mention you, while going to Ottawa, he has a stopover in Heidelberg in Germany, where he actually have connection. So he got help from there, and then from their help, he built the whole, glass system that is needed for making converting the sample into CO2 and its purification, etc. And using these two, he started his activities. Facility was used extensively for archaeological studies in India. For example, the Pandurajar Dibi near Bolpur, which is actually dated using this facility. So this is already there. His radar measurement actually and evaluation of helium concentration work also started here when he was at Science College that Vikas has talked about a lot. Also carried out many administrative responsibilities as assigned to him by S.N. Bose, who was by that time the head of the department there. And then from there, his research work, he moved to Jadavpur University. So once you go to new university, you have to build everything from scratch. And it is nothing, new for him. He can do anything by that time. So special underground lab, the building there, he was building that engineering science building, you have the basement. He realized that is the best place for doing low background studies. So he made the lab, the lab should be located in that basement itself, not anywhere else. He set up immediately cloud chamber. Now he is not only talking about gas chambers, gas counters, you see that one? You need all different kinds of counters. He is now talking about cloud chamber, photographic emulsion, that was not his area. When he was in Bose Institute, Bibha Chaudhary was working on that. Scintillation detector that he has already, because he used these for studying the other thing that I am coming to, that machine shop, electronic and cosmic ray heart there itself. They measured the radiant concentration in the atmosphere and in the rainwater. This is a Nature publication that came up immediately. And measured the composition and identified components of radioactive fallout over Calcutta. That time all the nuclear test was going on and people are worried how much in the atmosphere these radioactivities are coming. So he measured all these components, alpha, beta, gamma, all these components. And that's what I'm talking about. For example, the scintillator detector is used for beta and gamma measurement, and then he measured also alpha from there. So he has moved from cosmic rays to environmental science and societal application for those things that is there. Again, the diurnal cosmic ray intensity variation at Calcutta with a Mason telescope that I'll come to in picture immediately, measured the low energy cosmic ray neutrons at sea level and measured the neutron energy spectrum of cosmic ray, which is producing low energy nuclear burst. So when the cosmic rays come, some of them will produce nuclear burst. So what is the energy spectrum of that cosmic rays and so on. So he was measuring all sorts of experiments there. And of course various improvement of performance of GM counters that he is continuously doing. For example, here I am showing you that Mason telescope that he has used in Jadavpur University. There are 3 layers of GM counter, and in this you can make a coincident circuit so that you can do even the direction, which direction it is coming, and you can trigger it accordingly and do it. So he built that one himself with his students there. There is the circuit here. So you have these 3 layers of GM counters. You take the coincident and then you start your recording. Whenever there is a particular direction a meson is coming, a mu meson is coming, you can do that one. Here is the pressure ionization chamber. This is to detect that low energy nuclear burst that I am talking about and measure the energy spectrum of the cosmic ray producing low energy nuclear burst. So he is a physicist of many splendors that Vikas has already said. A true instrument builder always used instrument developed by himself a tradition started by Acharya J.C. Bose, and he just followed it through. Probably one of the most important members of the Calcutta School of Cosmic Rays. I call it Calcutta School of Cosmic Rays, probably I'm picking that one because this D.M. Bose and all his students, Mriganko Sinha, Bibha Chaudhuri, R.L. Sengupta, and name it, there are such a large number of important people working at that time. So it is definitely not one single person, but a group of people. And you need a group of people to do this kind of experiment. So he was an important member because, when he built that cloud chamber at Bose Institute, you see, it's not a single person. He was expert in making the coincidence circuit that time. R.L. Sengupta and Mriganko Sinha was expert in cloud chamber. So they all put together their expertise and built it together. Introduced the study of fission physics, nuclear physics in India. He is the man who started nuclear physics in India, of course. Pioneered the measurement of environmental radioactivity, as I told you, all this radioactivity measurement due to this nuclear explosion and so on. And pioneered radiocarbon dating studies in India. So all different aspects you can see. So studied various aspects of cosmic rays. So this is his totality, but I will take 2 more minutes to talk about 2 more, some great people around that time. Just you should remember, he is not Mriganko Sinha. He was, I just going through his, again, working with D.M. Bose in cloud chamber, and I'm putting this one because I have, okay. So in 1943, when Homi Bhabha, still at IISc, and wanted to start a cosmic ray unit, and from there he wanted to start TIFR for a great place of experiment. So first instrument that TIFR started with a cloud chamber. And probably many of you do not know who built that cloud chamber. Actually, Professor Srikantan told me this story. I was too young to know that one. It was Mriganko Bose. Mriganko Sinha, he called Bose and then asked Mriganko Sinha to go to Bangalore and build a cloud chamber for TIFR. And that's the first instrument TIFR started, and after that TIFR has flourished in all areas of experimental science. It all started from Calcutta. So this is the linkage there. You should remember that. So, but see, this man, where he was? He was at Regional Engineering College, Durgapur, and he was there, he was building his detector there along with his colleagues and going work actually. And I was fortunate because he was my teacher in MSc. So this is one. And Bibha Chaudhary, of course, I don't have to tell this story again. She has done great work in the nuclear emulsion. Only unfortunately, they not, because of the World War, didn't have the enough resolution of this emulsion that he used, and so narrowly missed to the pi and muon separation that is required to convince the whole world that they are seeing both pion and muon in the detector. But they are coming from the same cosmic ray school of Calcutta. This is photographic emulsion. So let's go. Yes. So pioneer. So actually, this, if you later on you will see. Then when Cecil Powell got his Nobel Prize in 1948 for the same discovery, he actually mentioned about the work of Bose and Bibha Chaudhary, that this is the technique they have used, same technique, the method of measuring particle energy using multiple scattering. The same technique that they have devised here, that has been used them, but by that time they have much better high resolution nuclear emulsions. They could see easily the separation between them. So now that I told already, that Homi Bhabha's unit started with this detector here. Now, and from there we see that, maybe I'll stop here, but from there I'll just say that he picked up from the Calcutta School of Cosmic Rays, Homi Bhabha, and built the whole class of cosmic ray experiment there. That is basically possible because he could again put together, like Bose, a large number of people and then give them that work together. This cooperation and collaboration is the most important part. You cannot have a single person, even how great you are, to go beyond something. So we all, for the future, I want to tell you that remember that actually now this is again declining. It has declined long back in Calcutta. It has now even declined slowly in TIFR because nobody wants to make their hands dirty by building instruments. And that is the main problem this country is facing. Science is nothing without experiment. Science is nothing without experiment. Not only that, if you want to link science with technology development, in between you have to build instrument. Then only you will get confidence. And that confidence that people like Syamadas Chatterjee has brought in is missing. And I wanted to tell her that if you want to do something for the future, think about science means experiment. Thank you.
Thank you, Professor Jana. That was a very scintillating lecture, and even for non-physicists, it was very exciting. Thank you for briefing us. We now welcome Dr. Debashish Ghosh Professor Debashish Ghosh as the next speaker.
On Syamadas Babu and his work on helium. Okay. And in fact, Syamadas Chatterjee was of a generation which had produced many experts, okay, and all of them possess a definite ideology, motivation, and ability to stick to a problem despite failures, and vision for infrastructure building. Next. Of course, they started off as peripheral scientists, not like the scientific officers of government departments now. They created new scientific concepts, new experimental techniques, set independent tradition of scientific reason, and generated new ideas even at the start of their careers. Now, when Syamadas Chatterjee joined Jadavpur University, he also interacted and brought along with him constantly a flow of visitors from neighboring institutes, principally from Calcutta University, Hoshnaran Bose, Kedarashya Banerjee, who was the director of Indian Association for the Cultivation of Science, N.N. Ghosh, mathematician, S.S. Boral, Rishikesh Lokit, R.L. Sengupta, Jane Bhaur, Akshay Bose, again from Cultivation of Science, Nihar Dotto, Cultivation of Science, and Devji Bhai. Devji Bhai was a technician, camera technician of Satyajit Ray, and he used to come over to Syamadas Chatterjee to get into the nuance of how to take pictures in different shades, different atmospheres. Okay. Next. Now, this is a brief historical background of the helium extraction system that was put up at Cultivation of Science. It was in 1971 that Professor Bose had suggested Syamadas Babu to do some work on helium or extract helium, which was then known to be coming out from the Buckwheat gas. So in 1972, a helium extraction scheme was started, and by 1974, India exploded its first atomic bomb. Now, this was a crucial period because this is for the first time helium was used by the USA as a political weapon. All helium inflow into India was stopped. But by 1974, the Buckwheat helium plant started working. Well, the quantum of helium from the spring gas was not very much, about 106 to 180 liters per day, which was very small amount. But even so, it started working. In 1978, these helium research activities were transferred to VCC, and till now it is continuing with the helium exploration work at different areas. Next. Now, this is the apparatus that was built at the Cultivation of Science, a glass-blown apparatus, which could detect helium even in the air to a level of 5 parts per billion. Its accuracy was 5 parts per billion. And the sample gases that were analyzed really had more than 1,000 ppm or 10,000 ppm helium, so it was not very difficult to measure that sort of concentration with this instrument. This was a glass bone instrument designed by Professor Chatterjee, okay, at Cultivation of Science. Next. This is the photograph of the same equipment. Next. Now, you see, the helium content of many thermal springs. I have only shown 3 here, but many thermal springs, at least about 60 thermal springs in Jharkhand, Assam, and elsewhere were measured by the same instrument. And you just mark the nitrogen component is above 90%. In atmosphere, nitrogen is around about 78%. Here it is 90%. This implies, actually, what happens is the Earth, the crust of the Earth holds more than 50 times the nitrogen that is present in the atmosphere. So the nitrogen is very high. Next. Now this is the helium extraction laboratory built at Bakrosha, a wooden structure, for which the entire thing costed about 8,000 rupees to build it then, for which government paid 6,000 and Syamadas Chatterjee paid 2,000 to have this thing built. Next. Now, this was the first setup to extract helium from the spring gases. This was nothing but a pressurized or rather PSA system in which you send in the gas, cool it down, and then after some time helium comes out, the rest of the gases are then withdrawn and helium is transferred to the gas holder there. Next. Now, what are the sources of helium in the Earth? Okay. You see, the helium that was derived from the sun, that is within the Earth, is trapped still there and is known as the solar helium or loosely primordial helium. And that constitutes about 84%. In fact, the mantle of the Earth, where the helium is trapped, constitutes about 84% of the Earth's total volume. So a great deal of helium is still embedded inside, and that is leaking out. Second, by the alpha decay of extinct radioactive elements, francium 87, etc. Okay, they are very short-lived radioactive elements. And third, the radiogenic helium that is derived from the alpha decay of uranium and thorium that is still continuing. Okay. Now, the signature of these two groups, actually, the primordial helium and the radiogenic helium, is different. Primordial helium has a helium-3, helium-4 ratio, 10⁻⁶, and the radiogenic helium has a ratio 10⁻8. Okay. Next. Now, the helium production in the Earth's crust, actually, you see, if you take the average density of the rocks as 3 gram per cc, then the total amount of helium that is produced in the crust all over the world is 4.15 into 10⁶ per year, cubic meter per year. Okay. And this helium really exists in two ways. It goes into the rocks as discrete bubbles, or it is in association with other gases, okay, just as in hot springs or elsewhere, or in the water also. Next. Now, you see, if you take why is helium escaping from the West Bengal Jharkhand geothermal area? The thickness of the Earth's crust in this region is very low. You see, normally the crustal thickness is about 38 kilometers, but in this region it is only 24 kilometers. So the overburden pressure is much, much low in this region. Secondly, this region has got a very large heat escape rate, about 240 milliwatt per meter square per second. That is the heat escape ratio in this region, very high. Normally it is about 60 milliwatt per meter square per second, so it's almost 4 times the global average. Okay. So the heat is very, very low, so the thermal escape rate would also, for helium, would be low. And then the rocks in the region have got about 4% lower density. So all these 3 factors are favorable for helium escape from the Earth's surface into the atmosphere in this geothermal region. Next. Now, this is just a model showing the helium coming out right from the mantle as well as getting intermixed with the sedimentary cover. Okay, helium coming from the sedimentary cover and from the crust and goes into the air actually. Next. This is again a model of the same thing in a better fashion. Next. Now, you see, not only helium comes out, radon also comes out together. Okay. The radon profile is very broad. It takes a long area, whereas the helium is very sharp. Okay. Now, the advantage is when exploring for helium, it is always better to also measure the radon content, because with radon being a radioactive gas, even a single atom disintegration, you can pick it up in your counters, whereas for helium, to assess helium, you need at least 10 to the power of 16 atoms before you can assess, you get a detection level. Okay. Next. Now, this is a schematic diagram. You see the helium comes out almost just like as in the pressure cooker. It's not flowing out continuously, but it builds up the pressure, then suddenly it comes out. Okay. So this is a system that we had used to detect that. Next. You see, these are the curves. The helium goes from very low concentration, goes to high between 10 to the power 4 to 10 to the power 5, and then falls back within a time of 15-20 minutes. So these are there. Next, this is a experimental setup in the field for collecting the soil gas when the helium concentration is high. Next. Now, you see, if you take the average flow over a period of time, 15 minutes or 20 minutes, whatever it is, then you get helium concentration about 890 ppm, okay, and the soil gas outflow is about 10 cubic meter per hour per meter area, surface area. So the total helium availability is the average concentration into the average outflow. And so if you integrate that, you get about 8.6 cubic meter helium being released per square meter per day, which is about 485 cylinders helium, pure helium per year actually. Next. Now, that was at a place called Bhawanipur, not very far from Bakreshwar. But in Tatloi, the picture is different. In Jharkhand, if you go a little northwest, the picture is completely different. Here, the helium is coming out continuously from the surface. Okay. It's not in periodic bursts as in Bakreshwar. So you have got to put in a probe inside about 1 meter depth, and then the helium, measure the helium. Come on, next. Next. Yeah. Now, this entire thing goes on in Jharkhand area. Wherever you go in Jharkhand, right from east to west, that is even up to Palamau, you get the same helium values, more or less, as if they are fed by the same geothermal plumbing system. Okay. So, next, the previous. Yeah. Now, you see, if the total area of Jharkhand is 79,000 square kilometer, okay, almost a little above that. Now, if you take the hot spring area, then it's about less, so it's about 13,000 square into 10 to the 9 square kilometer. And from this 13,000 10 to the 9 square kilometer, if you calculate an average of about 6.82 million normal helium cylinders per day is coming out. Or if you take in terms of cubic meter, 47.8 into 10 to the 6 cubic meter per day is helium is coming out, whereas India's requirement is just 9.38 million cubic meters per year. That's 6.82 million cubic meter normal cylinders per day against 9.38 million cylinders per year. Next. Now, we had done up an experimental plant for extracting helium from the soil gases. Okay. So you put in a number of probes, have a compressor, goes to a gas holder, then goes to a drying unit, and then to a helium enrichment unit, which is, we constructed it ourselves using liquid nitrogen as the coolant. Liquid nitrogen was taken from Durgapur, used to be taken from Durgapur in flasks and then taken to the field station and purified for helium. Now, you see, the price of helium is continuously rising. Okay, you can see since from 1940 to about 2020, it is continuously rising. Now, picture this thing. If we invert it, what happens? It only means that the availability of helium is decreasing to that extent. So the increase in price indicates that the availability is decreasing. Okay, next. So now helium is a rare gas which is abundant in the geothermal areas of West Bengal and Jharkhand. Okay, but it is the red tape which is not so really that rare. So it's the red tape in government establishment that is one of the main causes of hindering the development of this entire effort. Okay. Okay. Thank you.
I would like to thank Professor Bikash Sinha, Professor Debashish Ghosh, and Professor Mondal for an extremely valuable and interesting insight, starting from Syamadas Chatterjee and where his research led to in the sourcing of helium and how much is available and what is the geopolitical impact of this discovery. Thank you all for a very, very interesting session. And I hand over now to the next session. Thank you all very much.